Hi everyone, let's take up a question on ray optics. In the diagram given below, there are three lenses formed. Considering negligible thickness of each of them as compared to R1 and R2, that is the radii of curvature for upper and lower surfaces of the glass lens. The power of the combination is. First of all, we will find out power of each lens as if they are kept in air. Then we will add up the powers to find out the power of the combination. So equivalent power would be equal to P1 plus P2 plus P3. For the first lens, upper surface has radius of curvature r equal to infinity as its surface is plane. The lower surface has radius of curvature equal to r1. The middle lens upper surface has a radius of curvature equal to r1 and lower surface has radius of curvature equal to r2. The third one, upper surface has radius of curvature equal to r2 and the lower surface is plane. Therefore, its radius of curvature is infinity. Let's use lens maker's formula 1 upon f equal to n2 minus n1 upon n1 1 upon r1 minus 1 upon r2. n1 in our case is 1. In the first case, let's find out power of the first lens. 1 upon f is the power only. So let's write it P1. This would be equal to 4 by 3 minus 1. Upper surface has radius of curvature equal to infinity. 1 upon infinity minus 1 upon minus r1. So this is equal to 1 upon 3 r1. Similarly, let's find out P2. P2 would be equal to 3 by 2 minus 1 multiplied by 1 upon r1. r1 is negative minus 1 upon r2. r2 is also negative. So this gives us 1 upon 2 into 1 upon r2 minus 1 upon r1. Now let's find out P3. This would be equal to 4 by 3 minus 1 into 1 upon minus r2, and second surface is plane, so its radius of curvature is infinity. So this is equal to minus 1 upon 3 r2. Now let's add to find out the power of the combination. P equivalent P1 plus P2 plus P3. This would be equal to 1 upon 3 1 upon r1 minus 1 upon r2 minus 1 upon 2 1 upon r1 minus 1 upon r2. and this would be equal to minus 1 upon 6 1 upon R1 minus 1 upon R2. So power of the combination is equal to minus 1 upon 6 multiplied by 1 upon R1 minus 1 upon R2. Alright, thank you.